If two things are positively correlated with each other, all it means is that as this thing goes up, this other thing tends to go up. Or if two things are negatively correlated with each other, it simply means as this thing goes up, this other thing tends to go down. A correlation is simply a number between -1 and 1 that describes the strength and direction of the relationship between two variables. But just because two things are correlated or related to each other doesn't necessarily mean that one causes the other. In fact, here's a few examples. As it turns out, there's a positive relationship or a positive correlation between the number of engineers in Kentucky and the average number of comments on a MrBeast YouTube video. Now, this obviously doesn't mean that as people comment on a MrBeast YouTube video, some engineer in Kentucky just spawns out of nowhere. And it obviously doesn't mean that as people sign up and become engineers in Kentucky that all of a sudden there's more comments on MrBeast YouTube videos. These two things are related to each other, but one clearly does not cause the other. It's just a pure coincidence that they happen to be related. On top of this, two things can be related to each other due to something called a mediator. For example, I could say your height is related to the probability you'll play in the NBA. In other words, as your height increases, the probability you play in the NBA also increases. In fact, here's a data analyst talking about it.
This is a chart, likelihood of American males of every height of reaching the NBA, where each inch roughly doubles your chances of reaching the NBA.
But that doesn't mean just because you're tall, that's going to cause you to play in the NBA. There's other factors at play. There's other reasons as to why you might play in the NBA. For example, if you're never introduced to the game of basketball, yet you're 7'5", well, you're probably not going to play in the NBA. That's just my guess. So a good mediator of how tall you are and your chance of playing in the NBA would be someone introducing you to the game of basketball. In fact, later in the same video, our data analyst says this.
So if you're 7 foot tall, we're really good. Maybe you'll be a gym coach or a high school teacher or someone on the street is going to spot you and say, have you thought of playing basketball? And it turns out a large percent of 7-footers in the NBA, including Hall of Fame 7-footers, didn't even play basketball until they were like 13 or 14 years old. And people are just like, here, try this, and they became Hall of Famers.
Another reason two variables could be related yet not caused by each other is due to confounds or confounding variables. This means there's some variable that has an impact on both of the other variables, sort of as a puppet master, but neither of the other variables have an impact on each other. It's really this third hidden variable that's secretly increasing both of these other variables at the same time. For example, it turns out the per capita cheese consumption correlates with the number of people who died by becoming tangled in their bedsheet. The more cheese that is eaten globally is correlated with the number of people who have died from suffocating and being tangled in their bedsheets. Now, does this mean that as people are eating cheese, that more people are just getting strangled by their own bedsheets? No, that's not at all what that means. The positive relationship and increase in both of these variables is likely due to other factors, like the number of people on planet Earth. As time has gone on, there's been more people on Earth, meaning there's more people that could die by strangling in their bedsheets, and there's more people to eat cheese. There's this hidden third variable of people in the world that's actually causing an increase in both of these variables at the same time. The correlation of people eating cheese and dying in tangled bed sheets is actually so striking and kind of funny, not really for the people who died in their bed sheets, but it was funny enough that this article was written about it. And in an article titled Of Cheese and Bed Sheets, a couple statisticians talk about the exact phenomenon that I just explained, and these are known as spurious correlations, when we think two things are related to each other and that's the end of the story, but really there's something else going on. As the article continues, they go on to talk about what a correlation is. And what a correlation actually is this scary formula right here. And it looks super scary at first, and we're not going to break down the math in this video. This is more of just a conceptual understanding, and there's a million resources out there to explain what each of these values is, but I pulled this up to show you that a correlation isn't just some magical number that's pulled out of thin air. But if a correlation can be pretty vague and maybe not the most meaningful thing in the world, as I've just pointed out with my examples, why do we care about correlations? Why do we care about them at all? Well, first of all, they help us paint a better picture in research. As science tries to learn new things and discover different mechanisms that's going on planet Earth or the universe at large, it's often helpful to understand first how certain variables are related, and that way, correlations help us paint a better picture of what's going on. They help researchers start to understand something which we don't inherently understand. But perhaps a more practical use of correlations is their usefulness in prediction. You might not actually care about how things work, you just care that they're related. For example, pretend you're a greedy business person and you start, your own movie theater. And as a greedy business person, all you care about is increasing your profits. All you care about is making as much money as possible. Well, if you collect some data and come to find out that every time you paint your floor, you end up selling more movie tickets, you end up making a lot more money. Well, do you actually care what the causal relationship is? Do you actually care why you're making more money when you paint the floor? Or are you, the greedy business person, just going to send one of your employees to paint the floor every day and get those numbers up? I mean, that's really what it's all about. Another big place you'll often see them used behind the scenes is in something like insurance. When you go to sign up for car insurance, they ask you a bunch of questions, and all of those questions come from decades of research showing what's related to you crashing your car, what's related to you getting into an accident. And they factor all of that in, they throw it into a big equation using correlations to find these predictor variables, and they spit out how much your insurance costs you. If you have any questions or are still unclear on what correlations are, how they're useful, what they do, why do we care, anything like that, just leave a comment. I'll see it, hope to answer it, and I'll see you next time.